Hello, this is Valentine from Simplistic, and in this problem we're going to take a look at how to figure out by looking at certain equations, acid-base reactions, which ones are the Bronsted-Lowry acid, which ones are the Bronsted-Lowry base, which ones are the conjugate acid, and which ones are the conjugate base. So before we kind of take a look at these specific equations, what we need to understand is that according to the Bronsted-Lowry theory, a Bronsted acid, let me write the acid out here. The acid is essentially a proton or an H plus donor, and a base is an H plus acceptor. Now when the acid gives away the proton, then what is left behind is the conjugate base. And so the acid gives rise to a conjugate base. So what's left behind is the conjugate base. And the base, once it accepts the proton, what it gives a rise to is the conjugate acid. So the difference between an acid and its conjugate base is simply going to be one proton, where the one that has the H plus, so the proton, is the acid. And the difference between a base and a conjugate acid, again, is going to be one proton, where the acid is again going to be the one that has the extra proton. All right, so now let's take a look at problem A. In problem A, we have this molecule reacting with water, and then notice carefully how this molecule accepts a proton. So therefore, this species is going to be the base. So I'm going to write base. And then since it's reacting with water, and water is the one that's giving its proton off, this is going to be the acid. Now, the base is going to give rise to the conjugate acid, which is going to be the one with the extra proton. So therefore, this is going to be the conjugate acid. I'm just going to abbreviate it as Ca, conjugate acid. And the acid out here is going to give rise to the conjugate base, which is going to be one proton. Okay, so that's the conjugate base. Take a look at the next problem. Again, we have HNO3 and H2O reacting to give us H3O plus and NO3 minus. Notice carefully how the HNO3 gave the NO3 minus. So the difference between HNO3 and NO3 minus is just one H plus. Therefore, this is the proton donor. HNO3 donated its proton. It gave rise to NO3, which is the conjugate base. And H2O in this case is the base, which actually accepts the proton to give H3O plus. So that's the conjugate acid. I hope that made sense. Thank you for watching.